guys, today we're going to have an introduction into radicals. A radical sign looks something like this. So a radical sign can be used for a square root, it can be used for a cube root. And so examples are the square root of 24. This is a square root. It has what we call an index of a 2. We don't always put a 2 there, but this is an index. And so we call this a cube root of 8. This means it has an index of a 3. This number on the inside that we call an index tells us, we call it a root, that we're looking for some number that we multiply by itself 3 times that would give us 8. And of course we know that that is 2. This number right here tells us that we're looking for some number that we multiply by itself that would give us 24. Well, that's not going to be a whole number. Right here, the square root of 100. If it's a square root, we don't normally write that the index is 2. You're looking for a number that you multiply by itself that will give you 100. This is going to be 10. The radical, or the square root, if there is an unwritten index of 2, we call this a square root. So to square root something, you have to figure out what number was squared or multiplied by itself. For example, the square root of 225 is 15, because 15 squared, or 15 times 15, is 225. And so the perfect squares, or numbers that you multiply by itself, are going to be 1 times 1, which is 1, 2 times 2, which is 4, 3 times 3, which is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6, which is 36, 8 times 8 is 64, 81 is a square root, 100, 121, 144, 169, 196, and 225, and that's up to 15. So we're going to find the square roots without a calculator. So again, this means you have an index of a 2. So the square root of 25 is 5. The square root of 100 is 10. So this number on the inside is called the radicand. This sign is called the radical, and the sign and the number, this is called the index. So this is a 10. The square root of 9 is 3. This 9 is called the radicand. The square root of 16 is 4. Square root of 36 is 6, because 6 times 6 is 6. Square root of 49 is 7, because 7 times 7 is 49, and so it has to be the same number. If there is a number in front of the radical, simplify the radical first and then multiply, because that means you're multiplying. So example, 5 square roots of 4. We would simplify the square root of 4 to 2, and that means 5 times 2, which is 10. So 3 square roots of 25 means 3 times the square root of 25, which is 3 times 5, which is 15. 6 square roots of 100 means 6 times the square root of 100, which is 6 times 10, which is 60. So if you can take a second and go work those problems out, and then we'll come back and compare notes. All right, so you should have negative 12, 2 square roots of 16 is 8, 5 square roots of 36 is 30, and negative 6 square roots of 49 is negative 42. So we just found the principal root, which is the positive root, because the square root of 36 is positive 6 times positive 6, but it's also negative 6 times negative 6. So for the lessons for today, we are just looking for the positive roots. We will be looking at the negative roots at a later time, but we're just looking for the positive root or the principal root. So we have a radical form, and this is what radical form looks like. It's like this is your radical sign. The A, this is what we call the radicand. I talked about that earlier. And there is an unwritten exponent, and so that E is your exponent, and this number on the outside is your index, and this tells you what your roots are going to be. And so this is your index. Okay, and so this is a radical form, and sometimes we write it in radical form and sometimes we write it in exponential. And so when we write it in exponential, it's a to the e over I. And so these are equivalent, they're just two different forms. And so this is your radicand, this is your exponent, and this is your index. So if you had something that looks like this, your radicand is your 7, your exponent is your 3, and your index or your root is 4. And so these are equivalent. This is radical form, and this is exponential, 7 to the 3/4. Just like if you had something that looked like this. This is the square root, which we don't necessarily write as a 2, but I put it here for these purposes. And so 8 to the 1/2 is another way of writing the square root. Just like if you saw something like this, this is the same thing as 16 to the 1/2, which is equal to 4. So they are equivalent. This means you take the square root, this is your radical form, this is your exponential, and this is simplified. All right, so I talked earlier about this square root of a to the, and we're going to change the n to an I, and so this a is what we call the radicand. This is your radical. Outside, this is your index. And then you have, I'm going to put a 1 here, this is your exponent. And so a to the 1, which is your e, and this is your I, just so that we can remember. Sorry, my cat's tail. E over I. So one more time, we have 8 and we have a 3. Just because we don't have an exponent, that doesn't mean it's not there. And so those are equivalent. All right, your perfect squares one last time. So I would take a second and write those here. Seven times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14. 15 times 15 is 225. All right, in order to simplify a square root that isn't a perfect square, and so say that you had the square root of 20, we have to find two numbers that multiply together to equal the radicand. The radicand is the number under the square root, and one of those numbers need to be a perfect square. For example, the square root of 20. You're going to write down all the factors of 20, 1 and 20, 2 and 10, and 4 and 5. You're going to pick the largest perfect square. You're going to always pick the largest perfect square. So we have 1 and 20, 2 and 10, and 4 and 5. Well, 1 is a perfect square and 4 and 5. 4 is a perfect square, but 1's not going to help you. So you'll always have 1 as a perfect square, but 1's not going to help you at all. So we're going to pick 4 and 5. Out of these choices, which pair contains a perfect square? We're going to rewrite the square root of 20 as 4 times 5, because 4 times 5 is 20. We're going to break down into individual ones. So you're going to have the square root of 4 and the square root of 5. And then we're going to simplify the square root of 4, because we know the square root of 4 is 2. We're going to leave the square root of 5 because we don't know what that is. So we're going to have 2 square roots of 5. So now let's do one together. So we're going to have the square root of 24. We're going to list all the multiples of 24. So we're going to have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So you look to see what is the largest, which one of these has the largest perfect square. The largest perfect square is 4. Not the largest number, but the largest perfect square. So we're going to use 4 and 6. So we're going to rewrite that as 4 times 6 underneath the square root. So we write the square root of 24 as 4 times 6 and give each number its own radical. So we're going to have the square root of 4 and the square root of 6. Now we can simplify the square root of 4, and so we know that the square root of 4 is equal to 2. So we'll rewrite that as 2 square roots of 6. We're going to leave the square root of 6 because we don't know that. All right, so the next one, the square root of 12. The process is always the same. We're going to start with always writing our factors. So we're going to write 1 and 12, 2 and 6, 3 and 4. Our perfect squares are 1 and 4. So you ask yourself, which one of these is the biggest perfect square? That is going to be 4, so we're going to use 3 and 4. We'll rewrite that as 4 times 3 underneath the radical. Now we're going to give each one of these their own radical. So it's going to be the square root of 4 and the square root of 3. I can simplify the square root of 4 with 2 because 2 times 2 is 4. And then I'm left with the square root of 3 underneath the radical. And so this is 2 square roots of 3. 5 square roots of 18 means that I'm going to multiply everything by 5 when I'm done. So the square root of 18 is going to be 1 times 18 and then 2 times 9. This right here are the two factors I'm going to use. And so I'm going to have 5 and I'll have 9 times 2. Break that down into individual square roots. Square root of 9 is 3. So that means 5 times 3 square roots of 2. 5 times 3 is 15. And then I bring down the square root of 2. So remember that you have the square root of 2 that is left underneath. The 2 is left under the radical. Square root of 21, the factors are 1 and 21, and 3 and 7. You're looking for perfect squares. And there are not any perfect square factors for 21. And so what this means is that this is prime. And that means that we cannot reduce the square root of 21. So we're going to leave that as the square root of 21 because we cannot break 21 down into factors that can be reduced. The square root of 32, we're looking for factors of 32, and they are 1 and 32. 2 times 16. And then we have 4 times 8 are our factors. And so we have 2 to choose from, 16, 2 and 16, and we have 4 and 8. And so we're looking to see which one of these is the biggest perfect square, either 16 or 4. I'm going to choose 2 and 16. If you choose 4 and 8, you will have to reduce that again because 4 is not the biggest perfect square. And so this reduces down to 4 square roots of 2. If you type it in the calculator, they will be equivalent but not simplified. We are trying to simplify this to its reduced form, and 4 square roots of 2 is as far as reduced as it will go. If you were to go ahead and use 4 square roots of 8, this becomes 2 square roots of 8, but there is a square root of 4 inside there, so you would have to go and break that down again. And this now becomes 2 times 2 square roots of 2, and that is 4 square roots of 2. So it's the same answer, it's just way more work. Square roots of 50 are 1 times 50, 2 times 25. Right here is your perfect square. So we'll break that down into 25 times 2, individual. And this becomes 5 square roots of 2. Last one is 1 times 200, 2 times 100, 4 times 50, and then 5 times 40, and I think there's one more, and it's 10 times 12. So we're looking for the biggest perfect square. So we can use this one, or we can use this one, but which one has the biggest perfect square? And it's 2 and 100. So we're going to have and so then we'll break it down into individuals, and that's going to be 10 square roots of 2. All right, on your homework, if you look on the very back, it says write in radical form. And so if you remember that you're going to have EA to the E over I is equal to, you're going to have your radical, and you have your A, which is your radicand, your E, and your I. So that is what you need to remember. So square root, the 7 to the 1/2, anytime you see the 1/2, that means the square root. So you're going to have the 7, exponent of a 1, and the 2. And so you will put that in formative. That just means the square root is 7. Looking at number 3, you'll have a radical. The 2 is the radicand, the 5 is the exponent, and the 3 is your index. And so you're going to simplify that. That just means 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. And so that's what that means. Looking at number 7, we're going to write this radical form in exponential. This has an unwritten 2 because it's an index, and that means that I have a radicand of 10, an exponent of a 3, all over an index of 2, so that's 10 to the 3 halves. Number 9, radicand of 2, exponent of a 5, index of a 4.